All right, Algebra 2. This is what I'm going to look like when I'm older. No, I'm not. I don't know what I'm going to look like when I'm older. That guy's awesome, though. That's Carl Friedrich Gauss. He was born a long time ago, a long, long time ago, and then he died after that. What did he do? He provided everything for our lesson today. He created the fundamental theorem of algebra, and that means that whatever the power is, right, is what it's talking about here. The degree. That's exactly how many roots we have. What's a root? That's a solution. That's an x-intercept. That's all those things. All right. So it means if something is x to the second power, we've talked about, we get two solutions. We get x equals, blank and blank. If it's to the 12th power, that means I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get 12 answers. All right, the thing that in Algebra 2 that we are prepared to solve are things that are quadratic. Some things that are cubic, right, we can factor those and get them down. If it's more than that, then we run into a little bit of trouble, and we want to make sure that we can handle what Mr. Gauss has for us. So let's put a few things together. How are we going to find answers that we don't have yet? Well, we're going to look at the graph. I'm looking at x-intercepts. Okay, so I get 2 and negative 2. And where'd that come from? That comes from way down here. Let me highlight down here. It goes through the x-axis at 2 and negative 2s. That means we got two solutions. Done and done. All right, now the next one, we got one real 0. And we dealt with this a little bit in solving quadratics, right? We said the square root of 0 gives us one answer. Well, we get that one twice. Okay, and the fancy word we use for that is multiplicity. Multiplicity. It's also a pretty funny movie. Right? And then if it doesn't go through at all, that means we don't have any real zeros. We end up with the imaginaries, just like all my friends. Oh boy. All right. So that means we took the square root of negative 3, right? So maybe we had 5 plus or minus the square root of 3 over 2. So you go 5 plus or minus I root 3, and it's over 2. So these are the things that can happen. But these count as two solutions. Right, this is two solutions. Remember, we talked about that as we did quadratic formulas. So what am I going to do? Oh, no, it says x to the 5th power. I don't know what to do with that. Yeah, you do. I gave you a graph over here, right? So if you didn't have that information, you would plug it into Desmos, be like, desmos.com. Siri, open desmos.com. And then you put this in here, and you're like, all right, so Alexa, tell me the answers. Well, Alexa doesn't, but Desmos told you that we should use negative 2. Now, keep in mind, this is a solution. So what I'm going to do is use negative 2. And I'm going to use synthetic division. Why? Because it's awesome. 1, negative 1, negative 3, 3, negative 4, and 4. Where'd those come from? Coefficients. And then we're going to add them up. 1, work down, negative 2, negative 3, 6, 3, negative 6, negative 3, 6, 2, negative 2 and 2 makes negative 4, and I got 0. All right, now here's the deal. If this is an x-intercept, like I see from the graph right here, I must get a remainder of 0. That has to happen. All right, if I get something else, then I messed it up. You know what I mean? I got to take ownership. All right, now, they're like, that's great. Now this is x to the 4th power, right? I'm like, well, I don't know how to deal with that because this isn't one of those factoring x to the 4ths. What should I do? Let's find another intercept. So this time I'm going to divide by 1. Let's do all of this again. Now don't start over, okay? So what I'll see eventually by the time we get to the chapter test, I have kids that divide the whole thing by negative 2 and they go back to the original and start over. Don't start over. We've made progress. We've made progress. So we're going to keep going. Drop it like it's hot. 1, 1, negative 2, negative 2, 1, 1, negative 2, negative 2. All right, now I see this happened on my graph, right? So I have to get a remainder of 0. And what are we going to do? We're going to do all of this one more time. What number are we going to use? Positive 2. Now, the order that I do these, it doesn't matter, right? Because they're all three supposed to be solutions according to the graph. So pretty sure they are. Been doing this problem for a couple of years now. I know, right? You're like bored with it the first time. I'm like, I've been doing the same problem for a couple of years. All right, so 2 times 1 is 2. I add those to get 0. 2 times 0 is 0. I add those to get 1. And then I get 2, and I get 0. And this one's on the end, so that's supposed to be my remainder. Okay, so this was x to the 4th. This is x cubed. This is x squared. This is plus 0x plus 1. So we definitely don't need that thing in the middle. So I'm going to drop that out. X squared plus 1 equals 0. So there's supposed to be 5 answers, right? 1, 2, 3, 4, 5. We see 3 of them in the graph. So that's 3 of my answers already. The last 2 answers are inside of this equation. So what we're going to do, we're going to solve it. Why? Because we can. Subtract 1. And we're going to take the square root. What's the square root of negative 1? Plus or minus I. Now that's positive I and negative I. That's positive I, negative I. Positive 2, positive 1, negative 2. Oh my goodness, that's all 5. We have 5 solutions. Thank you, Carl. If I ever have any more children, I will name them Carl. All right, I'm just kidding. I'm not going to name him Carl. It's a nice name and all, but I'm not. All right, here we go. This time I gave you the graph again, but the equation's kind of a mess. So if you're going to go and you don't trust my graph, then go ahead and drop this in Desmos. But we're going to move all of our terms over. So I have x to the 4th plus 2x cubed minus 13x squared plus 10x, right? Because I'm going to subtract 13x squared and I'm going to add 10x to get it to one side so it equals 0. All right, what are we going to do? Well, let's take a look at the graph. I see 0, 0. You know why that happened? Every single term in my polynomial has an x. So I know, like, synthetic division's okay. Like, it's definitely better than long division, but this is so much easier just taking out a GCF. All right, so what I'll do is kind of check them off. How many answers am I supposed to get? 4. We're like, okay, Mr. Tolo, why am I doing this? Because there are 4 answers right here. I just want to show you that it works, right? These are the things that Carl proved for us. So if not for me, do it for Carl. All right, so the next answer, I'm just going to work left to right, right? The order doesn't matter. So negative 5. Remember, that is already a solution. So 1, 2, negative 13, 10. And I better get a remainder of 0, right? So 1, negative 5, negative 3, 15, 2, negative 10. Yes, I love when it works. Okay, so that was x cubed. So this is x squared. Right. The other numbers we had, 1 and 2. You know what? Let's just mess with the universe. Let's use the 2 next. No, he didn't. He went out of order. 1, 2, negative 1, negative 2. Yes, it worked. All right, so that means this is x minus 1 equals 0. All right, do I really want to do long division again to solve this? I don't think so. Let's just add the 1. So we can go x equals positive 1. So I got 1. And here's the cool thing, if I can get this to work. What are my solutions? 1, 2, negative 5, and 0. 1, 2, negative 5, 0. They all matched up. They all matched up. Oh my goodness. You know what I just saw? Right here. Once we get to quadratic, we could have factored this, right? I could say factors of 2 are 1 and 2. So we could have gotten those last 2 factors that way. So once you get to a quadratic, you can stop and go to a quadratic method. Yeah, I don't know why I didn't point that out. Let's look for it this time, okay? Oh my goodness. Well, we're going to have to do it because my graph only shows me 2 of the answers, and I just don't see the other stuff, but I'm supposed to get 4. All right, so let's start with negative 3, or you can start with positive 3. Doesn't matter. Just pick one, okay? All right, negative 3 it is. 1, 1, negative 7, negative 9, and negative 18. Bum, bum, bum. Bring down the 1, negative 3. All right, negative 2, I get 6. I get negative 1. I get 3. I get 6, and it's negative, and I got 18. Okay, so now you start to see why I always cross that one out. So this was x to the 4th. So this is x to the 3rd. But I have to use positive 3 this time, right? Those are my two solutions. Bring it down 1, 3, 1, 3, 2, 6. All right, we got rid of that. So that means this is x squared plus 1x plus 2 equals 0. So I got two solutions so far. I got those from the graph. I proved it by dividing them out. All right, what are the factors of 2 that add up to 1? No. All right, roadblock. Every place that I'm looking, it's not working. I can't factor it. A is 1, but B is odd. So I'm thinking quadratic formula. All right, so let's fall down the rabbit hole of quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. All right, and here's the other tidbit, right? I only have 2 that I see here, so I'm pretty sure the other ones are going to be imaginary, like my friends. Okay, negative 1 plus or minus, here we go. Square root of 1 minus 8 over 2. Okay, I like where this is going. Negative 1 plus or minus the square root of negative 7 over 2. And negative 1 plus or minus I square root 7 over 2. Remember, this counts as 2. If you don't believe me, write it as two separate ones until your hand cramps up. You're like, I can't write anymore. Okay, negative 1 plus I root 7 over 2. Negative 1 minus I root 7 over 2. We were supposed to get 4, so that's 2. We had 3 and negative 3, so that makes up all 4 answers. All right, we get some to check down here, and we'll work on that in class.